So in this video, in short, we are locating horizontal asymptotes. Horizontal asymptotes for rational functions gives you the end behavior, right? It helps you to locate or determine when a function is, let's say, um, approaching y equals basically a horizontal line when the value of x is increasing or decreasing, meaning x is approaching infinity or x approaching negative infinity. So it states, suppose r of x is equal to n of x over d of x is a rational function where n and d are polynomial functions. One of the things about polynomial functions is that you can identify their highest power, okay? The highest power of a polynomial is called the degree of the polynomial. So if the highest degree, which is degree of n, is equal to the degree of d, then your horizontal asymptote is simply going to be the horizontal line y equals ratio of leading coefficients. If the degree of n is less than the degree of d, then the horizontal asymptote is y equals 0. And if the degree of n is greater than, if the degree of n is greater than the degree of the denominator, then r has no horizontal asymptote. So let's just look at some quick examples here. Let's say if I gave you this function, f of x equals 17 minus 100x squared over, you said Diablo? Oh, oh okay. And that's what it sounded like. 20x squared minus 55. All you care about with this function in terms of finding its horizontal asymptote are the degrees of the numerator and the degrees of the denominator. Well, what is the degree of my numerator? In other words, what is the highest power in the numerator? 2, right? It's the highest power of the variable term, which is 2. What is the degree of my denominator now? It's also 2. So since these two degrees are equal to each other, then the horizontal asymptote is defined as the ratio of the leading coefficients of that power. Right? So our HA in short, horizontal asymptote, is y equals now the coefficients. What is the coefficient of my x squared term? What is the coefficient of my x squared term in the numerator? Careful, it's negative 100. Right, we have a minus in front of that 100. So it's negative 100 over what? Over 20. Now, can you reduce this? Yeah, you're going to get what? Well, negative 5 over 1, which is just simply negative 5. Right? 100 divided by 20 is simply 5. See you tomorrow. So you get negative 5. And that's it. Let's try it again. Let's look at another example. So that way you get the hang of it. Let's say g of x is 200 x to the 17th power. I don't know. Plus 100 x to the third power minus 45, all divided by x to the 20th power minus 100x to the fifth plus 3x. All you care about is the highest power in the numerator, highest power in the denominator. So what is the degree of my numerator? N. 17. That's the highest power. What is the highest power in my denominator? It's 20. Now compare those two numbers. Is 17 equal, less than, or greater than 20? Yeah, it's strictly less than 20. So by our rules, we say that if the degree of your numerator is less than the degree of the denominator, then the horizontal asymptote is just y equals 0. So in this example, horizontal asymptote is y equals 0. That's all you got to say. By the way, if anybody here taking calculus, there's a problem on the final exam that talks about limits. Computing a limit as x approaches infinity. That's equivalent to finding a horizontal asymptote for a rational function. So if you know this down pat, then you know one question already on the final exam for 175. All right, here's part C. Oh, that's the rule. If the degree of the numerator is smaller than the degree of the denominator, it's equal to 0. The reason why is that the denominator is growing larger for values of x that you plug in as x approaches infinity, let's say. As the x values get larger and larger, the bottom is growing faster than the top. So the bottom, you're going to have a big number. The top, you're not going to have as of a big number, but since the bottom is much, much bigger, you're going to see that it approximates to 0. Okay. Let's try it again with part C. Let's say if I have something quite simple, like h of x equals 4x cubed over 2x plus 5. All right. Well, anybody can tell me what's my degree of the numerator, and somebody tell me what's the degree of my denominator. Degree of the numerator is degree of your numerator is 3. That was a tongue twister just now. And the degree of your denominator is 1. Now, compare those degrees. Is 3 greater, less than, or equal to 1? It's strictly greater. So because it's strictly greater than 1, we know that now there's no horizontal asymptote. That means that the function essentially increases or possibly decreases without bounds. In this case, because everything is positive, it looks like it's increasing without bound. All right, that's a little bit about your end behavior of, or locating the end behavior, your horizontal asymptotes.